Hello, my name is Scott Mesjian, and today I'll be doing the second problem for week 2 of discussion section 8. This is problem 59. A tree loses water to the air by process of transpiration at the rate of 110 grams per hour. This water is replaced by the upward flow of sap through vessels in the trunk. If the trunk contains 2,000 vessels, each 100 micrometers in diameter, what is the upward speed of the sap in each vessel? The density of tree sap is 1,040 kilograms per meter cubed. So immediately what we can see is that we're solving for speed, and we have this flow rate of water, this mass flow rate. So let's try to uh, draw this out. So let's pretend this is a cylinder, and these are the capillaries basically that the tree is using to uh, get the sap up. So now remember that the diameter of these is 100 micrometers. So the radius is 50 micrometers. Additionally, we were given that the density of the tree sap is 1,040 kilogram meters cubed. And one more thing we were given is the mass flow rate of the sap. So we can write that as Qm, because Q is flow rate, so mass flow rate is Qm, and that's 110 grams per hour. Writing that in SI units gives us 3.056 times 10 to the negative 5 kilograms per second. So now we're going to need to use flow rate to essentially solve this problem, and the relationship between flow rate of volumes and masses. So the volumetric flow rate given in the book is QV equals VA. However, since we know that we're going to have 2,000 of these capillaries, let's write this out as QV equals NVA, and just have N as our 2,000, so we can substitute that in later, so that we know we have 2,000 of these. Additionally, we know we are solving for the speed at which this travels, so let's rewrite this in terms of v, velocity. So that is just qv over na. Additionally, we need a relationship between qm and qv because we need to substitute this 3.0 value in. So we know that the qv has units of meters cubed per second. Well, mass has kilograms per second. So um, I'll just write that out, kilograms per second. So, and we know density has this, has these units, kilograms meters cubed. So essentially this allows us to write these three in this relationship I will show. QV is equal to QM over P. Notice that if you wrote QM over P, the units kgs would be on top, kg over s would be on top, and kg over m would be on the bottom. And kg would cancel out, meters cubed would be on the top, and seconds would be on the bottom. So that does indeed work out in terms of units, and it makes sense because the volumetric flow rate would be the mass flow rate over the density. So now what we want to do is plug this in, but we also should notice that this area is here, and I still have not given the area of this circle area. So I mean, I'll give that to you. So that's just pi r squared, simple circle. Just going to imagine those capillaries as circles. So now all we need to do, we're almost done here. Plug these in. So Qm over P, and that's our density, remember, of the sap, number of capillaries times pi r squared. Now, if we just write that out even simpler, we'll get n p pi r squared. So now all you need to do is just plug those values in. We have all of them here, n's here, p is here, and r we have here. Obviously, you can convert that into meters, which is just, I believe it's just 5.0 times 10 to the negative fifth, I believe. And yeah, after you do all that, you get a velocity of 1.87 millimeters per second. And that is your final answer.